Welcome to Astronomy Daily, your daily dose of space and astronomy news. I'm Anna, and we've got an absolutely packed show for you today, filled with groundbreaking discoveries from across the cosmos. We'll be diving into fascinating new research that suggests black holes might hold the key to understanding dark energy. And we'll explore an incredible discovery of one of the fastest spinning neutron stars ever observed in our galaxy. We'll also look at NASA's innovative new Solar Observatory headed to the International Space Station and discuss the upcoming mission to map water on the moon. But that's not all. We've got some exciting findings from the James Webb Space Telescope about planet-forming disks around failed stars. And we'll wrap up with the latest intriguing discovery from the Perseverance rover on Mars. So stick around as we journey through today's biggest space and astronomy stories. Our universe is a mysterious place, and one of its biggest puzzles has always been what exactly makes up most of it. Would you believe that everything we can see and touch, all the stars, planets, galaxies, and even us, only accounts for about 5% of the universe? Scientists have long wondered about the other 95%, and now they might be onto something big, involving black holes of all things. A whopping 70% of our universe is made up of something called dark energy, a force that's driving the universe's accelerating expansion. It's been doing this since the cosmos began its inflation 13.8 billion years ago. The remaining 25% is dark matter, which we can only detect through its gravitational effects on galaxies. Now, researchers think black holes might help us understand how dark energy works. As Gregory Tarl from the University of Michigan explains, black holes are the only places in today's universe where gravity is as strong as it was at the beginning of time. His team suggests that when massive stars collapse into black holes, they might actually be converting matter back into dark energy, like a cosmic recycling program running in reverse. This theory is getting support from observations made by the Dark Energy Spectroscopic Instrument, or DESI, which uses 5,000 robotic eyes to study the cosmos. The team found that as new black holes form from dying stars, the amount of dark energy in the universe increases in a corresponding way. It's like watching two sides of the same cosmic equation balance out. What makes this discovery particularly exciting is that it's no longer just theoretical. Scientists can now actually test these ideas through observations, watching how black holes might be coupling with and growing alongside our expanding universe. They're studying tens of millions of distant galaxies to track how fast the universe is expanding at different points in its history, giving us new insights into how dark energy changes over time. Whether or not black holes turn out to be the source of dark energy, this research is pushing us closer to understanding one of the universe's most fundamental mysteries. And that's what makes astronomy so fascinating. Just when we think we've got things figured out, the cosmos throws us another curveball to unravel. Next on the agenda today. In an exciting breakthrough from the world of astronomy, researchers at DTU Space have discovered one of the fastest spinning objects ever observed in our Milky Way. Using an X-ray telescope mounted on the International Space Station, they've identified a neutron star that's spinning at the mind-boggling speed of 716 times per second. This remarkable celestial object is part of what we call an X-ray binary star system, located in the Sagittarius constellation near our galaxy's center. Known as 4U1820-30, this system is giving us an unprecedented look at one of the universe's most extreme phenomena. To put this discovery in perspective, let's talk about what we're actually looking at. This neutron star is incredibly small, only about 12 kilometers in diameter, but don't let its size fool you. It packs a mass 1.4 times that of our sun into that tiny space. Sitting about 26,000 light years from Earth, the light we're seeing from it has been traveling toward us for 26,000 years. What makes this system even more fascinating is its companion star, a white dwarf about the size of Earth. This pair performs an incredibly fast orbital dance, with the white dwarf completing its orbit around the neutron star every 11 minutes. That's the shortest orbital period we've ever seen in systems like this. The gravitational forces at play here are intense. The neutron star's powerful gravity pulls material from its companion, building up on its surface until it triggers violent thermonuclear bursts. These explosions release energy comparable to an atomic bomb and can make the neutron star shine up to 100,000 times brighter than our sun. This discovery isn't just about breaking speed records. It's providing us with valuable insights into the life cycles of binary star systems and how elements form in our universe. It's another piece in the puzzle of understanding these fascinating cosmic objects that push the boundaries of physics as we know it. Next up, in groundbreaking news for solar research, NASA is preparing to launch an innovative new instrument called Codex to the International Space Station next November. This cutting-edge solar coronagraph will give us unprecedented views of our sun's outer atmosphere and help unlock the mysteries of the solar wind. What makes Codex special is its unique ability to not just observe the sun's corona, but to measure both the temperature and speed of the solar wind as it forms. Previous coronagraphs could only capture images of plasma density, but Codex's special filters will provide a much more complete picture of how the solar wind evolves from its birth at the sun's surface. The timing couldn't be better for this mission, as the sun is currently at its solar maximum, a period of peak activity in its 11-year cycle. This means Codex will be able to study different types of solar wind that are only present during this active phase, including fascinating blobs of hot plasma that form when magnetic field loops open up and release their contents into space. One of the key mysteries Codex aims to solve is why the solar wind reaches such extreme temperatures, about 1.8 million degrees Fahrenheit, which is remarkably 175 times hotter than the sun's surface. It will also study how this superheated plasma accelerates to speeds of nearly 1,000,000 miles per hour as it streams outward from the sun. This mission builds on years of research, including ground-based experiments during solar eclipses and high-altitude balloon tests. Now, by placing Codex on the space station, scientists can finally observe the sun's corona without interference from Earth's atmosphere, giving us our clearest view yet of these fundamental solar processes. Understanding how the solar wind forms and evolves is crucial for predicting space weather, conditions that can affect everything from satellites to power grids here on Earth. Just as meteorologists need to understand atmospheric conditions to forecast hurricanes, space weather forecasters need to understand the environment through which solar storms travel. Codex will provide vital data to help improve these predictions and protect our technology-dependent society. Now, moving on to another mystery that's about to become one step closer to being answered. NASA's ambitious Lunar Trailblazer mission is gearing up to solve one of the moon's most intriguing mysteries, the presence and behavior of water on our celestial neighbor. While scientists have long suspected water exists on the moon, we still have many questions about where exactly it is, what form it takes, and how it moves across the lunar surface. Set to launch next year, this compact but powerful satellite will orbit just 60 miles above the lunar surface, creating the most detailed maps ever of lunar water distribution. Using two sophisticated instruments, the high-resolution volatiles and minerals, Moon Mapper and the Lunar Thermal Mapper, it will track not just where water exists, but also its abundance, chemical composition, and how it changes over time. This mission could be revolutionary for future lunar exploration. Understanding the moon's water resources could help establish sustainable human presence on the lunar surface, as water can be processed into breathable oxygen and even rocket fuel. But beyond practical applications, the data could also reveal fascinating details about the moon's history, much like how ice cores on Earth tell us about our planet's past. The mission will investigate whether lunar water stays locked in minerals or migrates across the surface in daily cycles, potentially forming frost in extremely cold regions before evaporating and redepositing elsewhere. This could help us understand similar processes on other airless bodies throughout our solar system. For scientists like Bethany Ehlman, the mission's principal investigator, these findings could even provide clues about Earth's own water origin story. By analyzing the chemical composition of lunar ice, particularly in permanently shadowed craters, researchers might finally determine whether the moon's water arrived via comet impacts or emerged during its volcanic past. Speaking of space mysteries, in an exciting new discovery, the James Webb Space Telescope has confirmed for the first time that planet-forming disks exist around brown dwarfs in the Orion Nebula. These fascinating objects, often called failed stars, appear to have the same potential for planetary formation as their larger stellar cousins. Located just 1,500 light-years from Earth, the Orion Nebula has proven to be the perfect laboratory for this groundbreaking research. Using Webb's superior infrared capabilities, astronomers have identified at least 20 brown dwarfs surrounded by protoplanetary disks, the same kind of structures that give birth to planets around normal stars. The smallest of these newly discovered objects is truly remarkable, measuring at just 5 times the mass of Jupiter. That's a mere fraction of our sun's mass, yet it still maintains its own disk of gas and dust. 2 other objects were found right at the boundary between brown dwarfs and proper stars, with masses about 3/4 that of our sun, making their exact classification a fascinating puzzle for astronomers. This discovery challenges our previous understanding of how planetary systems might form. These flattened clouds of gas and dust surrounding brown dwarfs suggest that even these cosmic underdogs might have the potential to form their own family of planets, despite never achieving true stardom through nuclear fusion. The findings open up exciting new possibilities for planetary formation theories and suggest that planetary systems might be even more common in our galaxy than previously thought. With hundreds more potential brown dwarfs in the Orion Nebula waiting to be studied, Webb's continued observations could reveal even more surprises about these mysterious objects and their potential role as planet hosts. Now, let's head over to Mars for an update and yet another intriguing discovery. As NASA's Perseverance rover approaches its 4th year exploring the Martian surface, it continues to make fascinating finds. The latest comes from a nighttime image taken at a location called Serpentine Rapids, where the rover has spotted something unexpected: patches of green coloring within the red Martian rocks. Using its Sherlock Watson camera, Perseverance captured these intriguing features while examining an abrasion patch in a rock formation known as Wallace Butte. The green spot, measuring about 2 millimeters across, stands out dramatically against the rust-colored Martian landscape. What makes this discovery particularly interesting is that similar features on Earth typically form when liquid water seeps through sediment before it hardens into rock. The process triggers a chemical reaction that transforms oxidized iron, the same compound that gives Mars its distinctive red color, into its reduced form, creating these greenish hues. While microbes can play a role in this process on Earth, the green coloring could also result from decaying organic matter or chemical interactions between sulfur and iron. Unfortunately, due to the challenging positioning of the spot, Perseverance wasn't able to conduct a detailed analysis with its sophisticated instruments. As the rover prepares for its next adventure, ascending the steep terrain of Jezero Crater's rim before leaving the area it has called home for 2 years, this discovery adds another piece to the puzzle of Mars's potentially water-rich past. These green spots might be telling us an important story about the red planet's ancient environmental conditions and its potential for having once harbored life. And that wraps up today's fascinating journey through space. I'm Anna, and we've covered some incredible stories today, from the mysterious connection between black holes and dark energy to a record-breaking neutron star, exciting developments in solar studies, lunar exploration, and those intriguing green spots on Mars discovered by Perseverance. If you'd like to dive deeper into any of these stories or stay up to date with the latest developments in space and astronomy, head over to astronomydaily.io. There you can sign up for our free daily newsletter and access our constantly updating newsfeed. While you're there, check out some great deals from our sponsors and catch up on all our previous episodes. Don't forget to join our growing community on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Until tomorrow, keep looking up and stay curious about the cosmos.